is 3.4 homework on exponential functions and models. And so on number 1, what we have, it says let's let the world's population p in billions be a function of the number of years t since 1985. There should not be a they there. All right, so no they. And so here's our table, and so 0 corresponds to your 1985, and then 5 is 1990, and so on, right? So 20 would actually be what, 2005, right? 20 years after 1985, so 95, 2005. And on the right we have the population of the world, and so you can see that it's growing. So in 2005 it was 6.467 billion people, and the first thing we want to do is we want to plot the data. And so first we have to get the data into our calculator. So if you take out your calculator, under the statistics button, that's where we put in data, and you hit enter, and then we'll just hit 0 enter, 5 enter, 10 enter, 15 enter, and 20 enter. And so those are our years. And then for L2 we'll put our output, so 4.845, 5.279, 5.689, 6.085, and 6.467. Right, check the data one time just to make sure everything looks good. So I think it checks out okay. All right, so we want to plot our data. So you hit y equals, go up, make sure your plot's on, so highlight it, and then remember, okay, your calculator knows the data, it knows you want to plot it. Now you just have to tell it where to look. So you go to zoom stat, hit enter, and you get a nice looking plot. So what we need to do now is plot this data. So we draw a vertical and a horizontal axis, and put the little rectangles on there as well as you possibly can. Right, so it looks almost linear, even though we're going to use an exponential. Label your horizontal, so you have 0, 5, 10, 15, 20. Right, this is the time t in years since 1985. And for the output, we can look at the window and we see our output starts about, say, 4.5 down here, 4.5, and goes up to about 6.7 billion people. And so right here, maybe this is the population. P, make sure you put in billions. And then we can title this World Population. Okay. And so in part B now, it says use exponential regression to find a, and that should say exponential model. So let's fix that. So this should say exponential function. That will model p as a function of t and graph this function on your plot above. Okay, so on the calculator, just hit your stat button and go over to calculate, and then scroll through all these, and we do exponential regression. So go to exponential regression, hit enter again, and out pops our answer. All right, so here we have y equals a times b to the x, and they give us a and b. This r is actually what's called the correlation coefficient. We're not going to worry about it, but it tells us really how closely the data fits the function we found. So if it's really close to 1, it's a pretty good fit. So you can see it's kind of close to 1 here. So it's actually a pretty good fit. But what we care about is just this top part, a and b. And so on here, what we're going to do is, our output, they're using y. Ours is p, so we'll say, p of t. is equal to, and it says round regression parameters to 3 decimal places, so we'll write down 4.887 and then times 1.014 to the t. And we want to plot this function, graph this function on the plot above. So hit y equals and 4.887 times 1.014 raised to the x. And then just hit graph, and we should get a pretty good graph going through these 2 points, these 5 points. Right, so we just try to approximate as best as we can. Just something like that. And we move on to the next question, part C. And it says, use the model to estimate the population in 1985. So remember, the population in 1985, that's when t is equal to 0. So that's really the initial value, so that's just this number right here. So that's 4.887 billion people. And then on part D, all right, part C was this number. I bet you in part D you use something with this number. So it says use the model to predict the yearly growth factor and percentage rate of growth. All right, so the growth factor, right, this is the number you're multiplying by each time. So the growth factor is equal to this number, the 1.014, and the percentage of growth rate, so the percentage growth rate. Remember, you ignore the 1, so rip off the 1, and you get 0.014, so it's 1.4%. So population seems to be growing almost, so 1.4% per year.